Hello, welcome back to our class again. Once again, we are on our electrostatics class, and today we are dealing with resultant force on charges in a triangle. Charges in a triangle. So let us consider Q1, Q2, and then Q3. Let's consider these charges. And let's say Q1 is positive, Q2 is positive, Q3 is negative. Okay, or we can just make any of them positive or negative. Good. So this is Q1, which is positive. This is Q2, which is also positive. And then this is Q3, which is negative. Okay, good. Now these charges are arranged to form a triangle. Okay, they are arranged to form a triangle. Now let's make it clear here that the angle between them here is 60 degrees. This is also 60 degrees. Good. And the distance between this and this, let me call this x, let me call this y, let me call this distance z. Okay, good. Now we want to find the resultant force on the charge Q2. So we want to find the resultant force on the charge Q2. How do we go about this? The first thing that we have to do is that we have to look at the charge Q2 and see all the charges that are having effects on that charge. So I'm going to redraw the diagram again. This is plus Q1. This is minus Q3. This is plus Q2. Good. Now we are considering Q2. So what is happening here? This is pushing it. So this is applying a force in this direction. So let's call this F1 in this direction. The distance is x, right? So we can say that F1 is equal to K, Q1, Q2 all over x squared. Good. Now let us come and look at what this is doing. This is also attracting it. So this is causing an attraction. So let me call this force F3. Now the distance here is y. So F3 is going to be equal to Q2, Q3 all over y squared multiplying the constant k. Now remember, the negative sign is just helping us to indicate the direction of what the force is. Now the aspect which is more important, which I want us to be straight on, is how to get the resultant force. How to get the resultant force. Good. Now once you have seen the direction of the forces, what you do is that you have to bring just those two forces out. So I have F1 here and I have F3 in this direction. So these are the two forces that are having effect on the charge Q2, which is also positive. So let's just write Q2. Now what happens is that once you have seen the direction of the forces on the charge Q2, you are going to use either the triangle of vectors or the parallelogram of vectors to find the resultant on the charge Q3. So that is how you go about this. Okay, now let us just complete this one and then see where to move on from. Okay, so from the diagram we can use either the triangle of vectors or the parallelogram of vectors. This is F1, this is F3. So since this is coming here, this is 60 degrees anyway. Since this is coming here and this is also going this way, then we can draw a resultant to meet this so that this becomes F of R. We can draw the resultant to meet it that way so that that becomes F of R, so that we can use F of R to represent the magnitude of the resultant force. In doing that, we know, or we all know, that F of R squared should be equal to F1 squared plus F3 squared plus 2 multiplying F1, F3 cos of what? 60 degrees. So this is how we go about it if we want to use the parallelogram of vectors or the triangle of vectors method to solve this question. So you look at the direction. Okay, so this is the direction of the force. So if the force is opposite, then this has to be negative. So this is how you go about it. Or better still, once I have this and I have this is my F1, this is my F3. I can decide to elongate this one or elongate any of them. Let me just redraw the diagram. So I have F1 and I have F3. If I elongate this and this becomes my F3, this is 60, it means this is 120. Since this vector is meeting this vector, then I can draw a parallelogram out of it this way so that this one becomes the resultant force. So this becomes F of R. So from here to this is a parallelogram, and then we can say that F of R squared is equal to F1 squared plus F2 squared plus 2F1 F3. Sorry, it's F1 and F3. So F3 this way plus 2F1 F3 cos of the angle that is here, which is 120 degrees. So that if you multiply, you realize that cos 120 and cos 60 are equal in magnitude but opposite in direction. And therefore, if you multiply it through, you realize that you are going to be having the same answer. So you can use both the triangle of vectors or the parallelogram of vectors to solve this question. Okay. There can also be situations where you have that same charge. Let's say this is plus Q1, this is minus Q2, and then this is minus Q3. And then you are asked to find the resultant on the, let's say, the minus Q3 charge. Okay, no, let's all of this be negative. So let's find the result on the positive Q1. So find the resultant on the positive Q1 charge. I think we can do it this way. All right, so for something like this is how you can go about it.